Yeah. They are one session behind. Okay. See you. So this lecture is pretty theoretical, but that's, I think, the last one, which is oriented towards only diagramming. Normally, you should land on this one. So normally in lecture 1, we have seen what was class diagram. Yes? Huh? Excuse me? Huh?
Oh, attendance.
Yes, you were all absent because there was no attendance. So it's like this. You will have a penalty. But I have said that already to the administration. So normally they should not take it in account. Okay. Yes, so in last session, we have seen what was a class diagram, right? And what is the purpose of class diagrams? It's what?
To show like the objects.
Okay. If it's a class diagram, it does not show any object. But you remember what's the difference between, we say that we wanted to avoid the word object from now, to not make the confusion between class and instance. Okay? And sometimes object is in between in the comprehension of some people. So this is why I prefer to speak about classes. Classes, the class diagram is here to let us know the structure of our program. And especially, it is especially useful for me in the way it makes the inventory of the data and how it is organized in the application. Okay, so it's like an organized inventory of the data we will manage in the application. Of course, we can include in the class diagram way more than only that, but if we have at least the data, it's super good, okay, because it can be a good starting point for us. Okay, so what we have as well is we have different types of diagrams. We have, of course, the class diagram that we have seen. What will be the object diagram? The same, but with the living instances. Honestly, we are I've never used it. We have the components diagram. We have the package diagram. We have the deployment diagram. Those are less used in development. What will be useful for us is use case diagram, activity diagrams, and sequence diagram. This is what we are about to see today. To make it in short, use case diagram is to represent the features of an application. Imagine that you want to brand something, to market something about data science, a tool that you have done. you will have to identify the features that are connected to this tool and how they can be used. Bonjour. Bonjour. You forgot. It's bonjour, then sorry. Okay. Then the activity diagram shows bonjour. Huh? Ah, yes, there was a change of room. You're excused. It's an excuse generator. That could be a good tool to invent for EPITA students. Could have a market for this. Then the activity diagram shows the path once you are in a feature, the concrete list of activities that composes this feature, and actually how they are connected together. So what should I do in step one? Then the choices I can do in this feature, etc., etc. So mainly the implementation. And the sequence diagram, maybe you have seen that in the network fundamentals. It's to identify a protocol. When you have to say how components should interact together within your application, then you can use a sequence diagram to identify a specific way to communicate between each component. Okay, the use case diagram. It's very simple. We have actually two main components, the actor and the use case. The system being the frontier between the user and the features. Okay, so the use case diagram looks like this. Okay, you have an actor that can consume features, and features can be connected together. Okay, so here, for instance, include, okay, the process of checkout is complete only when the payment is done. Okay, so even this line is actually implicit, okay, because there's no make payment if there's no checkout, okay? But here we place all the features of our application and what actor is doing what feature. So that is helpful when you have, for instance, when you have, for instance, the identification of the roles composing your application. It is good to understand what is missing. Sometimes you don't have a clear idea of what should be done for what actor. Here, actually, it states what should be done. Understood? So it's a bit theoretical, but honestly, it helps. Of course, with 4 features, it's super okay. But if you have 15, it can be a bit a mess in your mind. What could be done by what, by whom? And that is actually a good way to organize. You see, I've talked about include and extend. Here, the extend include is a way to say we need the other feature we need the targeted feature for the current feature. So we need make payments for checkout. Okay, so it's mandatory. Extend, so when there's the extend keyword here, it is the case, for instance, for navigation menu. When you have your access to the menu, you can access to a specific feature thanks to this menu. So it's a possible follow-up, but it's not more mandatory. Okay. We have the generalization, so it's looking like the inheritance symbol, but this time for the actors. So when you have an actor that extends another actor, it means that the super actor can, the specialized, actor can do whatever the other actor can do. For instance, I give an example. Do you think it's true to say that an admin can do all that what a user can do, plus some specific things. Okay, so if I do that, then I will organize what can do a user, a regular user, and then the admin will extend that user to add the specific admin things. So it includes everything that the user can do, plus some specific features. Okay, we will not go that far into these details. For us, it will be only actors. And inside, there will be users, there will be admins, there will be, I don't know, customers or whatever. So in order to practice a little bit, I would like you to take a piece of paper or a diagramming tool. Okay, and here would like to use this symbolic, okay, to represent the use cases diagram that goes with that exercise. So library management. Every detail is listed here. So you have only to remember what is the purpose of everything, but to organize under the form of a use case diagram. Okay. So here you have two options. Mermaid is not the best to use to do the use case diagrams. You can use Draw.io, which is not bad, but you can as well use whatever you like. Actually, I'm using Mermaid here to simplify the way we can export things, but it's not the only tool. So you have Draw.io, you have other things. So you have here in the UML, if you want, you have all the use case. You have the container. For instance, here, that could be a member. What could a member do? Borrow a book. And borrow a book needs to be conditioned by search book. To borrow a specific book, we need to search the book. So this is where we need I don't see the connector. It's weird that I don't have the extents. Here it is. It's not extend in that case. It is include. Okay. Then what do we have? We have return book. If I
Excuse
take,
me, sir. I have a doubt.
yes,
How is it first borrow books and then search books? Because first we will search the book and then we will proceed to borrow it, right?
it's true. But when you say include like this, it means that this is to be that's like mandatory before borrow book.
But in the previous scenario, you said first checkout to be done, then payment to be done, right? For the
No,
include case. So here, then extend will come, right?
no, it includes because actually, in order to borrow a book, you need first to search a book. It's like to complete the checkout, you need first to do the payment. So there's a dependency, but this is required to complete borrow book. We need to search book. You see, this is how you could translate it.
Okay. Okay.
Okay.
Okay.
And of course, the member can also directly search. Maybe let's take only search. And if he wants to borrow, it's like this. Then return book. Okay. So, actors. We have the member. We have the librarian as well. Sorry. That. And you see, as the librarian can do everything that what a member can do, we can use the extend. Does not want to show, but we can do things like this. So the librarian extends the member so it can do everything that it can do, plus some specific things. For instance, in the can add a book, remove book, manage members. So 3 other features that can be done. Add book. Actually, to simplify, we could say manage books, manage members. Okay, let's not be lazy. Let's do add. Here, those features are only here for the librarian. You see that in order to remove a book, we need to search a book first, because we cannot say we need to remove it. So we need to access to it before. So here at Kane, it's a case for include. We cannot remove a book if we have not searched it before. Let's go back to the spec. Add book, manage members, search book, borrow book, return book, view borrowing history. Oh. So we have as well view history. Okay. There's no pay fine here, but it is say it here as an example. I will just add it so that you have an idea of the what's the difference between include and extend for the actions. So return book may be extended with pay fine. Like this. Is that okay? So if I know how to read this diagram, I can understand that the librarian extends the member capabilities in terms of features, so it can do all those things, okay? But it has as well some specific things that a member cannot do, okay? And it has manage members is not assigned here. And there are some specific things that are interesting to notice is that here we have the include. Before to borrow a book, we need to search a book, okay? Before to remove a book, we need to search a book. So those are induced in the feature. We cannot have the remove book feature if we don't have the search book feature executed before, okay? Here, the difference between include and extend, here the pay fine is optional. It's not always, okay? So the return sometime can be connected to a pay fine, okay? It can trigger a pay fine feature. Okay for you guys? Yes? Okay, we'll see at the exam.
So, excuse me, sir.
Oui?
So that means pay fine capabilities will be done by return book also sometimes.
Exactly. It
Okay.
can be done, but it's not always.
Okay.
Okay, just I will share this with you. So mainly thanks to that, we can see the behavior of the application, but organized by role and by feature, which is important when you want to have a big direction. To let you know in terms of project management, did you get any project management course so far? Okay, so you have seen agile methods, etc. Okay, so here, for instance, each group of function can be considered as epic in your application. You know what's an epic, right? In agile methodology. Okay, an epic is a group of feature that you'd like to connect to when you describe a user story? Have you seen user stories? Okay, a user story is a description of a specific part of a feature. For instance, the borrow book could be an epic in your case, and you can have several user stories that describe how the borrow book should behave. When, as a user, when I do this, then I should have this. As a user, when I try to borrow a book which is already borrowed, I have an error message. As a user, when I borrow a book which is free, then I'm proposed to pay or something, okay? So the user stories are describing epics. So these features can be considered as epic depending on the grain of how you have organized your project. Okay, activity diagrams. The purpose of activity diagram is to organize the process, to visualize the process, okay, and to make sure that you have all the steps to complete an algorithm. If you remember in the technical warm-up, we have seen those kind of activity diagram to describe an algorithm. Here, it's exactly the same. When you have a critical part of the application which should be described, for instance, if you have a very specific process to register, I don't know, orders or to register users or whatever, if it is important and not easily described using text, you can use this kind of flowchart, this kind of activity diagram to do this. So the rectangles are activities, the diamonds are choices, okay? So you can have several outputs. Normally one rectangle is having one output and one input, and a choice can have one input and several outputs. You can see that first step is this kind of notation. Last step is this kind of notation. Okay. You can have as well swim lanes, but here it's not well represented. The mermaid is not exactly made for that. Maybe Plant.uml would be better, or even Draw.io here. But the goal is to have the idea of what is done by what actor. You remember the librarian, member, etc. Here we would define one swim lane per actor, and then we see what activities and ensured by what role in the process. Okay, so you have here conditions. And here could be interesting that you do this exercise. Okay, do me this properly, and then we can take a break. Yeah. What's your name? Okay. It's good. Okay, so let's create another one. So this is the start, this is the end. This is an activity. Okay. So let's try to maybe just have this here. User insert card. So this is the start. Let's connect start to here. System validates the card. Then I have a choice. If invalid, okay, let me just replace the connectors. It will be easier to continue. Okay. System validates. Is it valid? No. Maybe I just forgot to print another activity, which is here, show error, and then quits. eject card. If if valid, ask for pin. Ask pin. Enter pin. Pin correct. Then we have two choices. No. Then we ask pin. Maybe before that, we can have a max try. No. Yes. Yes, here. Block. Card. And end. If pin correct, show menu. Select withdrawal. Enter amount. Check balance. Sufficient balance. If insufficient, show error back to menu. Yeah. If sufficient, dispense cash and print receipt. Okay, we don't have it here. Sorry, but actually the symbolic to do parallel task is here. Print receipt. And eject card. Hmm. And end. Okay, so this is the visual representation of the same process you have understood. The only thing that was a bit difficult is to find this component, but otherwise it's pretty straightforward. What could help as well is to have the swim lanes to organize this per role, because here we have the machine itself and the user, that it's not clear here what is doing what, whom is doing what. But okay. You have any question regarding the activity diagram? It's pretty easy, normally pretty intuitive. Okay, let's do a break. Let me share this with you. Good. So let's have a break, 10 minutes maximum. And then we do the sequence diagram, and then we'll see how to initialize the Java environment. Yeah, sorry. Yeah, but you can just move the next. You're welcome. Okay. What's your name?
Shamal Deepak.
Hmm?
SHY. SHY. YY.
Why, sir?
Yeah. This one. Thank you.
You're the Batman?
Fine.
You're the Batman?
Yes.
Come on, back in five. It's virtual, so you can check that from what I can see you from the invalidation. I think there's an issue here because you do not control how many times so maybe after 3 attempts, just go for the cut. So, so if you want to modify or to take for you the diagrams, you can just click on modify here, and it will load the diagram in edition mode. So you can inspire as well from here or completely take it for yourself, no problem. Huh? Okay? So don't hesitate. Okay, let's resume. So the purpose of the sequence diagram is to organize things over time. I mean, to organize interactions over time and to see what are the steps, but this time more like communication wise. Okay, so the key components are the lifeline. So this is like a line that will show what is interacting with what. Okay, so you will see that it is a vertical line and some messages can come from that line to another component line. The activation box means that it's showing when the object or instance is activated. What does that mean? That means that whenever you call an instance, a component, it will activate, okay? What's the way to activate an instance? By using a method against that. So you are calling, for instance, if we want to take back the ATM example, the user is activating the ATM by entering the cards into the machine. Okay. Synchronous message, it's the same. It's an arrow. And here the synchronous message is actually, what's the concept of synchronous message? What's the effect? Is that we have to have the answer, the response, before going to another step. We return the message. We have then the asynchronous message aspect, where we can actually do another task right after having sent the message. We don't wait for the response, and we have a self-call. So this is an example here of sequence diagram. Here we can see several things. You can see that actually every component that we see here is an instance. So we enter the credential, we validate, we find the user, we return the user data from the database, we check the password, we return the results, and we show the results. You see that nothing happens here in between because this was synchronous. Now, if we have async, it can happen that we can trigger another call before having to wait for the original response. What is missing here, I think, is the activation box, but that is okay. You have as well different ways to group sequences, subsequences. Within alt, it's when you have to do if else. Within loops, okay, within parallel, and within reference to have access to another sequence diagram. So this is a case with alt, which is the if else, so alternative process. We request the server does a query over the database, and then we have two choices: either the data are found and we return success, either the data were not found and we return 4-4. Here the same, but with a loop. So we repeat that sequence for each item in the cards. Shh. Guys, you are late, so please keep quiet. Okay? So here, this is, I think there's an issue here in the diagram because it should not be solid if it was asynchronous, because you can see that here we do 3 things in a row without having to wait for the response. Okay. So when you can, in terms of best practice, just invoke the methods that are really existing in the instance, the instance you are calling. Show the return values if it is possible. Do not try to make another a too big sequence diagram because it will not be readable. Usually we organize left to right. We try to minimize the crossing, so it means that in this case where we have 4 components, the user plus 3 instances, Of course, it is better if the database is at the end, because otherwise it will be less readable. Okay, so try to optimize so that it is easier to read for your audience. Okay, do this exercise now using the online purchase sequence diagram. What you can do, if you want, you can take the code which is here and copy paste it to Mermaid, to the Mermaid editor. You have access to the slides. It's when you click on this curly brackets, you can have the Mermaid code which is behind. You take it and you use it to as an example to complete this exercise. If you want to use other things than Mermaid, feel free to. Okay, so here you have the list of components. So it's easy already to find your path. We have 1, 2, 3, 4, 5, 6 components. If I were you, I would reuse what already is here. For instance, this one. And I would go to Mermaid, for instance. So this is the diagram that I copied from the example found on my slides. And now let's focus on what is to be done. So we have customer, web UI, card service. So let's copy everything here. Of course, it will break. Does not like it, apparently. Let's switch that way. The advantage of using this text-based diagramming is that you can just mentally visualize what you should get. Should be readable, actually. Okay. And what did he say? We should create a sequence diagram. Customer clicks checkout on web UI. Customer web UI checkout. Then web UI gets card total from card service. Web UI card service get total. Then the card service checks each item availability with inventory service. Okay, so here this is where we have a loop. So you have an example of a loop here. Let's have a look. Looks like this. For each item in cards, the card service will check items availability with inventory service. Check availability. Then card service web UI sent payment to payment gateway. Use the alt fragment. So we have an alt example here. If payment succeeds, what do? We reserve items. Oops, it's the function here. Probably it will be in the inventory service. So this is web UI to inventory service. And then web UI to email service. Success email, else. Payment failed. Web UI. To customer. Show error. What we can say here maybe is that we have to have a web UI to customer show success. Okay, should be okay. Let's check. We check out on the web UI, we get total on the card service. Then for each item, we check if the inventory service is against the availability service, the inventory service, if the item is available. Then maybe we should return here somewhere. We should return to web UI or to card from card service. So this is where. Card service to web UI. Okay. Then we send the payment. And maybe here as well, the inventory service can respond. But we could have two cases if the item is available or not. And here it's not very well said. So let's to card service available. Then we have verified, we send the payment. Then we have two cases. If the payment succeeds, so here we could have here the payment gateway to web UI success. And here error. At least we have a return. We reserve the items. It is not said here that we have to respond, but I will implement it anyway. Inventory service to web UI success. And of course, here we should have maybe alt stuff, email service. Sometimes we don't wait for the success for the email response. We just go back. So here in that case, it should be async message. The symbolic for async message, normally it's the same arrow, but with no head. It's like an empty arrow, only the branches, not the plain arrow that we see here. And then payment gateway, the other case, the payment failed. So we have an error, then we show the error to the user. I think it is consistent. So I'm sending this to you. Okay, guys. So here it's, I would say, not maybe crucial, but if you see a sequence diagram, at least I hope that you will be able to read it. And when you need to set up a protocol with external entities, at least it shows in what order you are expecting them to be called or to return some messages. So it's important when you want to design your system that you have this in mind. Okay, let's go for Java quick setup now. Have you been able to install IntelliJ and Java? Okay, good. So it means that you have this tool now. Let's create a new project. Wait, UML, Java DSA. So here I've started IntelliJ and asked to create a new project. So it is asking me a folder for that. Okay, and I will create right after that a module called bank. Called Java exercises. The build system will be IntelliJ and the JDK, as I said, 21. Okay. I will create now a new module called bank. So this is how it looks like in IntelliJ. You have a base module, which is the root of your project, actually. And you have some modules that can happen where you have all your the components, I would say, of this main project. Here, the goal is that we see some different cases that we have seen during UML design and that we try to implement in Java. Okay. You can see that the module here has a SRC folder, and the SRC folder will contain all your Java files. The goal of this first bank module is to represent the UML class diagram. If you remember, we have done an exercise with a bank system for the reference. I think I've shared with you, not sure. I did share this. Huh?
We did the library.
We did the library, but here it will be the bank. But you did as well the bank. It's only that it was, how can I say that? It was shown, but maybe we did not take time to do it with you. I will take it from the other group. Here it is. Here it is. So I will share it with you as well, but it's one of the exercises that you have in the first module. It's a system that will allow you to manage data for a bank. So we have an account, we have a customer, we have a stock that can be bought through an investment order thanks to stock orders, and we have a savings account. You see that there's a link between customer and account. Do you remember what's the meaning of this link? It's aggregation. Aggregation. It means that we have, we need from the account a customer. And why is that white here, empty diamond? Because the account is not strongly linked to the customer, which means that there's no dependency between them. The customer does not need the account to survive, does not need the account to be described, okay, to have a sense for the system. So meaning that if I delete the account, the customer can remain. Here the same, the stock order is connected twice with stock and investment account, which means that with white diamonds, which means that if I delete the stock order, the stock survives and the investment account survives as well. If it was plain, you have a comment? You have something to add? Okay. Was it about UML or Netflix or game or something else? Okay. Just, it's okay to chat. I was a student. It's a long time now, but I chatted as well with my colleagues, but just keep quiet as much as you can so that it's not, it's easier for your colleagues who want to follow. Thank you. So this is the class diagram that we are about to implement in Java. Let's start with the customer. The customer, as we can see, it has 3 fields, ID, name, and address. And what I want to show you here is that it is really easy once you have the class diagram to have the equivalent in Java. Let's create a new Java class. Something that I will not explain very in detail today is the package. The class, I right-click, new class. FR, EPITA, bank, customer. Why is that so long? Why do we have FR, EPITA, bank? Sorry, and we have even forgotten this. FR, EPITA is the organization for which I'm working. Bank is the name of the project in which I'm working. Data model is the feature or the component that we are trying to implement here. So this customer is not whatever customer. It's a customer that is participating from the data model of the bank project for the FIPTA organization. Okay, we will go again on that package notion next time. I'm creating this class, and you see that the package here is recalled, and we have public class customer. Okay. Then we have 3 fields. So you see, once we have this, we have almost for free the Java code, because the only thing that we have added is the Java declaration, okay, public class, etc., which was not stated in the class diagram, private, then the type, and then the name. But if I observe well, it's pretty direct to go from one to the other, back and forth, okay? Understood? So this is the first one of, this is at least one of the 2 phases that we have in Java. We have the modeling phase, and then we have the logic implementation phase, which is actually, here we are modeling what we want to use. We are doing components up to our own needs. So we are designing here a class that is supposed to represent the customer data. And the other parts of the Java development process is how to use this to make something. Okay, so I will create a new class, fr epita bank execution main. Okay, no, that's not good. That's created as a sub package. Okay, so here in the FA Petabank, I have 2 sub packages now. A data model, which is supposed to represent my class diagram, and an execution class, an execution package, sorry, which contains a main class that I will create, that I will transform into an executable class. It's good because it's in the execution package. And from there, I can use what I've designed here. You see that the customer that I've modeled, it's usable as a type in my execution code. So remember, 2 phases, we model, then we use, and by using, we discover that we have failed one part of the modeling. So we return to the modeling phase, and then we are okay to use it correctly in the execution part. Why is that important to not stay at a first round? Because if you do that, then you will not improve your model. You will not improve what you have designed here, okay? So do not do not be lazy. When you discover an issue with your model, update it so that you will benefit from it, from this update all along your development process, okay? Do you see here the 2 phases? Model, execute. It's a bit different from before, because beforehand you were towards execution. You wanted to execute only, and you do not spend time on trying to extract some reusable logic from the beginning. Here we try to do this from the start. We try to build some reusable things from the beginning of our project. You see that the first thing that I've tried to do is not to execute something, it's to represent the model, and then to use that model into my code. Of course, for now, my customer is pretty limited. It does nothing, but we will see in the next session how to use this, okay? So I only wanted to show you that once you have this, Java code is like this to represent the model. Of course, after that, we have subtle things to understand, but it's a big step. It's a big and important step. And even if you don't do UML, you have to have this kind of diagram in mind. With experience, you can have it without having to draw UML, even if it is still recommended for communication, etc., to have the UML diagram. But if you don't have it, you have to have this model in mind. Okay. Okay, let's do the attendance now. Aman, Amrut, Anila, Chandra Shekhar, Banu, Anita, sorry, Chun here, Divya Vaini, sorry, Emmanuel, Arshita, Gopi Chandu, change your picture, please. Jao, Janavi, Jaswant, Kishore, Manikanta, Magesh, Lakshit Saran, sorry. Mohammad Anis, Mohammad Roail, Nihal, Prerona, Nitya, Nishant, Prince, Richie Varma, Rohit, Sylvie not here, Sarvan, Sai Srinivas, sorry. Shiva Shankar, Sudeep, Suraj, Trinat, Tarim, yes, Surya, Vedant, update your picture, please. Venpadapu. I recall the goal of this picture is to help teachers to identify you. So here, cannot identify many things. Venkatesh, Yogesh, and Vrishika, sorry. Okay, thank you guys. See you next time. Oui.
To send this video in the team.
Sure, it's already.
So we have to
It's already recording.
So
You see, it will be uploaded automatically.
okay.
Yeah, you're welcome. You're not in the attendance list, so you have to tell Renata. At the office. I can't add you. At the office, yes. Yeah. Thank you, online people. Take care for those who are sick. And as a reminder, I cannot count you present if you are online, okay? If you are online and it's not an online lecture, I cannot count you present. So just for those who could ask the question, it's normal that you are marked absent even if present online. See you. See you when tomorrow? Today. Okay, it's data exploration with you guys. That's it? Okay.